Hello everyone, my name is Rong, and I'm a PhD student from the Hong Kong University of Science and Technology, Guangzhou. And today I'm going to present our work on behalf of my co-authors, Haichuan, Chuanzhang, and my advisor Dr. Kang and Dr. Zeng. PlantoGraphy is an intelligent system trying to incorporating iterative design process into generative artificial intelligence for landscape rendering process. Landscape renderings are realistic images showing landscape designs, allowing designers to evaluate the visual quality of spaces, and they can use it to communicate their design ideas with stakeholders. The traditional process for generating the landscape renderings usually requires designers to use different professional softwares in each step, like drawing the draft in the initial conceptualization step and using AutoCAD to develop detailed master plan of landscape, then model the design in 3D modeling software, and finally render the image using rendering engine. This process is time-consuming and also needs years of professional training. Recent advancements in AIGC provides a more efficient way. Designers can use text-to-image generative models, simply input design requirements to generate a rendering within seconds. However, existing AIGC tools primarily work in an end-to-end manner. It lacks the flexibility, which is unfriendly for designers to iteratively refine the outputs for common design practice. In particular, existing models may misunderstand the professional requirements from designers, like the location, number, and the type of the plants. So to fill this gap, we conducted online interviews with 5 landscape design professionals about the human-AI collaborations supporting the creative landscape design process. Based on the feedback, we summarized the design goals for our system. First, there is a feedback loop in the design process that requires iterative refinements along the way. It leads to the improvement of the result's graphical coherence to support iterative design. Secondly, designers need to control rendering details according to the professional knowledge. So we need to enhance the model's comprehension of landscape design descriptions, like the type of the plants. Thirdly, designers show a preference for multimodal interaction function. They think it helps them interact with AI in a more controlled way, acting more like a designer rather than a user. It leads to a third goal, interactive editing function for in-depth designer participation. To address the requirements, we propose a more controllable generative framework and design an intelligent system called PlantoGraphy. It supports the steerable generation of landscape rendering and iterative refinement. The controllable generative framework incorporates 2 stages to transform textual design concepts into realistic images of landscape renderings. First, the concretization module uses a graph-enhanced large language model to transform design descriptions into a concrete layout, and the layout will be used as the visual guidance and conditional input for the generative model. Specifically, we introduce SIGCHI as a bridge between text and layout. SIGCHI can represent the spatial relationships intuitively and enhance the large language model's ability to understand landscape design descriptions. Technical details can be found in our paper. Furthermore, interactive function can be designed based on the graph and layout. It allows users to make adjustments intuitively, which is one of our design goals. Next, the illustration module employs a fine-tuned layout-guided LoRa model. It takes the layout as input and transforms the layout into a realistic rendering. In this step, we conducted a vegetation dataset with valuable input of experts. The dataset includes plants that commonly used in landscape design. The OpenSet layout-guided image generation model can generate images for each plant in the layout box separately, which can avoid excessive image changes during iterative refinement. Furthermore, using the information of object ordering from SIGCHI can easily control the overlapping order of each object. More technical details can be found in our paper. Now I'm going to introduce our system design. Supported by this generative framework, we design an interactive system called PlantoGraphy. It provides a graphical-based editing function which is friendly for designers to express their design requirements. PlantoGraphy system allows users to input their design idea in text, including the style of scenario, the background description, plant type, and location. After input the text, click the Generate button. The scene graph and the scene layout will be automatically computed by the system and displayed in the graph panel and layout panel. User can click the Render button and the corresponding landscape rendering will be generated and displayed in the Render panel. Our system allows users to add or delete nodes in scene graph. Once the graph is modified, the layout will be changed correspondingly in Layout panel. User can further modify the design by changing the size and location of the bounding box of each plant. It's easy for users to iteratively change their design with the scene graph and layout. In the evaluation part, we assess the performance of the module separately from the use of the system. For module evaluation, we conduct 2 experiments to evaluate the performance of the proposed module, considering objective and subjective perspective. For the concretization module, we employed 3-dimensional quantitative metrics to evaluate the accuracy of the large language model-powered generator in transforming text into the layout. For the illustration module, first, for the design goals 2, we use structural similarity index metric and conduct a within-subject user study to see whether if the system improved the image's graphical coherence to support the iterative design. Furthermore, for the third design goal, we conduct a user study to verify whether our method enhanced the model's comprehension of plant-related knowledge. And the result shows the effectiveness of the reasoning methods and introducing layout control in landscape rendering generation. Furthermore, the result shows that the LoRa module successfully integrates plant knowledge into the model and enhances its ability to accurately generate plants. The generated cases can be found in our paper. For the evaluation of system design, we conducted a within-subject study with 6 expert designers. We tried to compare the AI-supported landscape design process using PlantoGraphy with the conventional design process using widely utilized industrial software. The result shows that, compared with the conventional softwares, the system is highly accessible and productive. It can help designers to save time in iterative revisions. Designers are satisfied with the quality of the generated images, matching the design requirements with a high degree of fidelity to the details. Furthermore, designers show more interest in layout panel and the environment setting slider instead of the text panel. We think it's related to the stage of the design process they stay. Based on the feedback from participants, we find some worthwhile questions to keep thinking about in our future work. First, in our workflow, the end-to-end generative process is broken down into multiple steps, allowing domain knowledge to be introduced into the model development process in various forms. Second, designing functions follow the target user's operational logic, can reduce the learning curve and facilitate smoother information transfer. Third, it's important to view AI tools as a helping hand for the designers instead of a replacement, because human expertise remains indispensable for ethical considerations, detailed understanding, and client prioritization in landscape design. We must pay attention to the critical trade-off, which is the specificity and accuracy of generated designs versus the diversity required by designers. To balance this trade-off, the weight of LoRa fine-tuning dataset collection should be carefully considered according to the designer's objective. That's all of our presenting. If you are interested in our research, please feel free to contact us. Thank you.